My name is Konstantin Pavlov. I'm a systems engineer at NGINX Incorporated. I work at a professional services department. And in this session, I will dive into the features of NGINX TCP and UDP load balancer we have in NGINX. So the stream module was introduced in 1.9 a year and a half ago, I think. But since then, it has become a quite mature and well-proven solution in addition to NGINX HTTP load balancing stack. I'll give some overview on supported load balancing methods, SSL and TLS support, and some additional features provided by NGINX Plus, such as proactive health checks. I'll show some configurations, some minimal and some not so minimal. I'll also share a few tricks using the stream module and nginScript, such as building a simple web application firewall. So let's begin. I'll just jump straight to the configuration, and for TCP load balancing, it's quite simple. As you can see, I'm defining an upstream block. First of all, I'm defining a... Does this work? Doesn't look like it's working. Oh, wait, yes. Yeah, but I can hear. Oh, yeah, here it is. So I'm defining a stream block in the NGINX main configuration file, and I'm defining an upstream block with two MySQL backends on my domain name. And then in the server block, I'm defining a listening socket to listen on the TCP protocol and proxying it to my defined backend. So it's quite easy and simple, and as you can see, there's quite similar to the HTTP configuration we have in NGINX. I'll show something more sophisticated in the next slides. But since version 1.13, I think, 1.9.13, I think, we also added UDP load balancing to NGINX. It serves two primary use cases: high availability and horizontal scaling of UDP services. So when the UDP datagram comes into NGINX, NGINX monitors the health of the backend services on either in passive mode using the passive health checks, or with the case on NGINX Plus, it will be using active health checks. And it will forward the connections, forward the datagrams to the servers that are alive. In this configuration, as you can see, I'm doing some DNS load balancing. I've defined an upstream block of two backends. The same thing goes for the listen directive, but I'm using a UDP keyword to tell NGINX to listen on UDP on this port. And one of the things that you need to keep in mind that in UDP load balancer, NGINX UDP load balancer is built that way, so it expects one or more responses, or optionally one or more responses from the backend. So in case of DNS, we're expecting one request and one reply. And I've also defined an error log to put the logs from a UDP load balancer with some kind of statistics to it. All right, so of course, we can fine-tune the TCP and UDP load balancer, and in previous slides, I've only shown the default configuration, which will use the weighted round robin. But there are also multiple choices to choose from. This can be a hash on a remote address, for instance, to enable session affinity based on IP addresses. And you can use the least number of connections. So NGINX will forward the request, the datagram or a TCP connection to a server that has the lowest amount of connections actively. And in NGINX Plus, you're able to use the so-called list time load balancing method, and you can choose the list time to connect, or to receive the first byte from your backend, or to receive the last byte, so the whole response. And in the right side of the slide, you can see how to implement that in NGINX configuration. All right, so of course, you can also define, as in HTTP load balancer, you can also define per server parameters such as weight, the maximum number of the connections that we considered as a failure if they fail, and the time during which those connections will be failed on the backend side. Of course, you can also mark the servers as down or being in backup. In nginx Plus, you can also limit the number of maximum connections to the backend, as described in the top 3 backends upstream group. So in this case, nginx Plus will not issue new connections if we have more than 20 already. The slow start parameter instructs nginx to gradually move the weight of the server from 0 to nominal value. So it can be useful, for instance, if your backend requires some kind of pre-warm, or so you wouldn't flood it with new requests as a big number of new requests. Also, you can use the service keyword to query the DNS SRV records to populate the upstream group here. And it requires the resolve parameter to be on as well, so you wouldn't need to restart nginx when the IP addresses change or there are some new entries in DNS for your service. All right, so as I mentioned on the previous slide, we had passive health checks enabled using the max fails parameter, but at nginx Plus you can also use active health checks, or asynchronous as they call them. So imagine we have a load balancer in front of multiple IMAP servers. Well, in this case we only have one, but that's because my slide wouldn't fit that many entries anyway. So imagine we have an IMAP server, but the status of the IMAP server is actually published on the built-in HTTP server. And we can instruct health checks to not use the IMAP's port to connect to, but we can use another port and to send and expect a specific request and response on there. That's what I'm doing in this match block. So I'm just asking for a status for this host, and I expect that will be 200 OK. I'm also checking the health check timeout to some lower value, which is because we need the health checks to not to time out, not to spend a lot of time in the check. All right, but of course in TCP and UDP world, you don't usually get to use clear text protocols, and for instance, for DNS, it will be necessary if you're implementing a health check. For DNS, it's necessary to send hex encoded data. In this particular slide, in this configuration, what I'm doing here is I'm sending the server a payload that asks for an A resource record for nginx.org. Well, you can actually check that in TCP dump, for instance. And I'm expecting for the server to reply with one of the IP addresses that are in the response. One of the major things to think about here is obviously you cannot just came up with a string like that, right? So one of the easiest way to get the requests and responses would be to, well, in my case, it was just a simple TCP dump, and I've copy and pasted basically that into the configuration. Yeah. Of course, in the stream module, it's quite similar to HTTP in some ways, and you can limit access control, and you can limit access to the resources in the module. So it's pretty much the same as an HTTP block, as I've said, and you can use deny and allow directives to allow specific IP addresses or subnetworks to access your service. You can use limit CAN and limit CAN zone to limit the number of simultaneous connections to the server. And you can limit the download and upload rate to and from the backend server if you wish to do that. All right, so one of the biggest problems of using the TCP and UDP load balancer is how do we pass the client's IP address, because your business requirements might need that. Maybe your protocol, which you're proxying, doesn't have that information. Of course, there are ways in HTTP to do that quite easy. You're just injecting the X404 header or something like that. But what can we do with in a TCP load balancer? One of the features would be, one of the possible solutions would be to use proxy protocol, HA proxy protocol. It can be enabled to the backend side by using the proxy protocol directive. And NGINX will basically wrap the incoming connection into a proxy protocol and include the client's IP address and the protocol it received the message on and pass it to the backend. Of course, that also means that your backend, which you're proxy passing to, it should speak proxy protocol as well. So that's probably one of the major downsides. You have to make sure your backend speaks that. Another way to pass the client IP address is to use the proxy bind directive and use the transparent keyword. What it tells here to NGINX is we're instructing it to use to bind to a socket to the backend using the IP address of the client. Unfortunately, that requires not only configuration on the NGINX side, but also to configure your routing table on Linux and mess with IP tables. But the worst thing about that is you have to make sure that your worker processes are using the super user route. And from a security point of view, that's something you most definitely want to avoid. So speaking about security, there are multiple ways NGINX does TLS with the stream module. The first thing to mention is that one of the first mode of operations is TLS termination, where you where you instruct NGINX to listen using the SSL TLS keyword, and you provide the SSL certificate and the key, just as you will do with your HTTP load balancer. And you're telling, with a proxy SSL directive, you're telling NGINX to strip the TLS off and forward unencrypted connection to your backend. That can be used, for instance, to make TLS non-aware application TLS ready. Another mode is to re-encrypt the connection. So basically, NGINX will listen on a specified socket. It will decrypt that, and that will re-encrypt that while connecting to the backend. So here, how you do it: you enable the proxy SSL to your backend, and you specify that you need to verify the backend with the SSL verify on and trusted certificate. And of course, another option to use TLS in NGINX is basically you're listening on a TLS-free port. You're listening on the clear text, plain text, or whatever you would call it, and you encrypt the connection to your backend. In the current release, there is a preliminary logging available. Because we all know that we need to do some analysis of what's going on with our load balancer, and things like that. And currently the logging, well, in current release, the logging is available in the following form. It's only in the error log, so you can see the client IP address in the port, and this is our IP address in the port our server is listening on. And then we can see that our server connected to one of the backends. And then the session ended. So basically, we transferred the following amounts of bytes to and from the client and to and from the upstream. It's pretty much the same for UDP, but we get to see the UDP designation here. One of the issues we had with that is you cannot really configure the log format of error log in NGINX. We've added that logging before we had any variables support in NGINX stream module, which is a TCP and UDP load balancer, and that's why it's so concise and cannot really be extended. Fortunately, 2 days ago, if my memory serves me right, maybe 3 days ago, we have added the possibility to enable access log for stream. In the next upcoming NGINX and NGINX Plus, you will be able to configure the logs in any way you would like that will serve your monitoring software or your log analysis software best. So it's not enabled by default, and you need to specify the access log directive in your nginx stream configuration file. By default, it looks like that. So basically, it's quite similar to HTTP, and it might even be parsable by one of your HTTP parsers, HTTP log parsers. So we're doing client's IP address, local time, the protocol. It could be either TCP or UDP in here. We're doing the status of connection, and we decided to reuse the numbers from HTTP because they are so familiar with everyone who are using HTTP or nginx. We're logging the number of bytes, the amount of bytes sent to the client, the amount of bytes that were received from the client, the overall time that it took to session to took for the session to go, and an upstream address, the IP address and the port of the backend the connection was served by. But of course, you can define whatever log format you would want and reuse any variables that are available in nginx. So speaking about variables, since 2 versions ago, or 1 version ago, you can create variables in the stream model, and that greatly expands the possibilities of the stream model because the configurations can be programmed in many ways. You can use the map module to build variables on other variables. It's pretty much the same as an HTTP block. You can use a geo model to build variables based on the client's IP address or networks. You can populate variables with a GeoIP geographic data by MaxMind. Split clients to enable A/B testing, so you can define different backends your request will go to. And of course, you can set variables and use them later via nginScript and JS set directive. I'm going to show it a bit later. All right, so that's how you can use it for a simple echo or discard-like server. I'm telling nginx to listen on localhost port 2007 on TCP and on IPv6 on the same port on UDP. And I'm instructing nginx to return the client's IP address I'm connecting from. Well, on my local, my MacBook, on my laptop, I'm doing with Netcat, I'm just connecting to my nginx running there. And as you can see, it will return the remote address, client's address there. All right, so another options to use the variables in stream module in TCP load balancer would be, as I've said before, is to use in GeoIP. From GeoIP, there will be variables populated by that module. You can use them in the limit con then, or you can use them in the proxy pass line. What I'm doing here is I'm splitting the clients based on their remote address. So half of percent of the connections will go to feature tests backend, so we can see if our features are doing good there, and everything else will go to production. Other use cases for variables include, but they're not limited to, you can use them in proxy bind, as I've shown before. You can use them in proxy SSL name directive that will instruct nginx to put the server name into TLS SNI connections to our backends. And of course, the access log, as I've shown on the previous slides. With nginScript, it's this configuration snippet does pretty much the same as on the other slide. We're returning the remote address of our client in response. So what I'm doing here in nginx.conf, I'm loading the module, the dynamic stream NJS module. Then in the stream block, I'm using the special JS include directive that instructs nginx to include the file called stream.js, which actually contains all the JavaScript code we'll be using. And in the server directive, I'm using the JS_set directive to set the value of the foo directive with the return value of the function from JavaScript. And then I'm returning that value in the TCP connection to my client. So in String.js, I would define a function called foo. The S is the session object, which is passed to that function by NGS by default, by nginScript. I'm doing some logging, so just to see if there is anything going on, and I'm returning the remote address, which is available as a built-in variable in the stream object. All right. Okay, so what I showed on the previous slide was some easy thing to do, and another thing that was going to be pushed anytime soon to NGINX will be filtering the payloads. You'll be able to actually pick into the data that goes through load balancing and make some decisions or change that traffic to something else. So you'll be able to modify the payload in TCP or UDP mode. I'm going to show a little demo of how would I implement the web application firewall, a simple web application firewall using nginScript. You can find the configuration and the JavaScript on the following link. It's going to be up there like in 10 minutes after I finish the talk. All right, so there it goes. Doesn't seem to work. Oh yeah. Yeah, so here's the NGINX configuration, and again, I'm loading the JavaScript module, dynamic module. I'm instructing to put all the logs into my standard error output because I will show it to you a bit later. I've defined the backend, which is my local machine again. I'm going to scroll a little bit lower to show it to you. I'm including the actual file that contains the JavaScript code. I'm going to show it to you a bit later. And I'm using the JS filter directive to define the function that will operate on the provided buffer from the stream module. The buffer is in the payload that actually goes there. And I've defined a simple backend, which a microservice you might call it, which returns the local time in the connection, you can see. So for the JavaScript code, it's quite simple, and here I am defining the function, the handler. It will be passed a session object as well. The next line, the second line, I'm checking if that buffer comes from the backend side. So in JavaScript, in nginScript, on each buffer, that function will be called, and it will be called on both on the data that comes from the client and the data that comes from the backend. So you can use the same function in both directions. So here I'm checking if the data is coming from the upstream, from the backend. I definitely do not need to pick into that kind of payload. So I just return, and nginScript will not be involved in operating on the buffers that come from the backend. So you might have heard about the shell shock vulnerability in Born Again Shell. It basically, I'm checking for, I'm doing a regular exploitation check on the buffer. Well, it's kind of easy just to show you what you can do there, but I don't think that the proper web application firewalls actually do that kind of things because it can be quite costly. And I'm running that regular expression check on the buffer I've just received from nginx. And if there is something going on, if that regular expression is matched, I'm going to show, I'm going to say it in the log file. There will be information that something was detected. And for HTTP proxy, which is basically happens when the client sends the proxy header in his request to try and persuade the backend server to send data through that proxy. Again, I'm checking the regular expression match here and aborting the connection so I wouldn't send any traffic to the backend. So let's see how it will work. So I'm launching the nginx. Some logging enabled there. Okay, so first I'm going to try and send some simple requests to try and take a look if my server is actually working, right? So yeah, there it goes. I'm going to do again go back to the configuration just to see the traffic flow. So basically, I'm sending the request to that server block, which will filter it using the nginScript and then send it back to this backend, which is supposed to return local time. Okay, so yeah, it looks like we've got a reply and we see local time in here. Okay, so far so good. Then we can see some some logging as I've shown before. So we can see the client connected to our server. We can see that our proxy connected to our backend. That's the access log of the backend, which goes to the same output as well. And then session ended, and we can see some logging of the bytes available for the in the error log for the upstream and for the client. All right, so now I'm going to issue well, for instance, let's start with a typical request of shell shock. I'm using a curl -h that instructs to put a specific header to the request, and I'm trying to see if it's possible to actually do shell shock on this service. All right, so I'm issuing a request. And I can see that curl did indeed add the needed header, and I received the response. But did our web application firewall actually trigger the check? Oh yeah, and here in the logs we can see that we have detected shell shock. So yeah, seems like it's working. So far so good. And we can see that we've logged the request here. Same thing. So it went all the way to the backend, and you can see that that also in the next line you can see that some bytes were sent to the backend as well. All right. So, but what if I do the HTTPoxy thing, right? I'm doing the same header as I did in the previous example. I'm adding a proxy header with directing our backend to go to evilexample.com proxy. But as you can see, curl sent the request there, and they received no reply from the server, which means that nginx that was staying in front of your backend had actually saved the day. And we can see in nginx logs that there was some the connection from the client came. Then we connected to our backend, but JavaScript detected that there is something fishy going on, and you can see the logging here. And nginx was instructed to abort the connection, and that's exactly what happened. As you can see, we received some bytes from the client, but we didn't send any to the backend, and we didn't send anything to the client as well, and we just closed the connection. All right, so that's one possibility to do, and another thing will be to modify the buffers we receive from the client, but that's not really covered in here. But that's also possible, but you have to be extra careful about fiddling with the buffers there, because it can easily lead to weird things going on. All right, so yeah, you will find the configuration and the specific examples on that link. All right, so but that of course is if you're doing some processing in JavaScript that requires some performance hits. So what I basically did there is the first two. Let's see. The first two scenarios I've tested, I did some performance tests, and they were really preliminary, and they didn't contain much of the tests at all. I've used one worker on NGINX, and I've measured the amount of requests per second in a typical scenario where HTTP backend is covered by a load balancer. So as you can see, just enabling the JavaScript resulted in around 10% of percentage drop in performance. The no-op means here that is I'm passing to a JavaScript machine, I'm passing the function handler, but it's not really doing anything, it just returns from the function. So basically I'm invoking the JavaScript JavaScript code, but not doing anything. It results in about 10% performance drop. Sorry. Things do get worse though when I enabled regular explosions on a JavaScript check, and that went all the way down to minus 30% of performance. But I think that's a somewhat expected thing, because all the web application firewalls that do in-place filtering, they are slow. They are really slow. Those are numbers from my 2010-year-old Xeon, so they probably will be quite different for you, but the overall percentage should be like that. I should also add that I didn't do any good performance tests other than that, and I'm yet to try and figure out what would be the slowness in NGINX implementation. It's scheduled for the next couple of weeks. All right, and so what to expect from the NGINX stream and TCP UDP load balance in the future? At the moment, we're actually kind of exploring the possibilities, so if you have any ideas and features that we would like to see, we're more than welcome to discuss them. What will be committed soon is we will parse the TLS SNI coming from the client, and we will populate some variables to use, for instance, in proxy pass. So you can check what's in a TLS connection in SNI. You receive the server name of your requested server, and you can forward it to a specific backend if you would like to. The next thing to be committed also is the proxy protocol support on the listening side. So we will populate the variables like remote address from the proxy protocol as well. Yeah, so that will be the additions in the near future. But then, and again, I'm asking you, if you have a specific use case which is not covered by the stream load balancer, please come to our booths and share. Right, so we also have a few documentation places on our website for TCP and UDP load balance in our admin guide. We have a couple of blog posts, more to follow actually, on TCP and UDP load balancing. And for nginScript documentation, please go ahead and check the source code, and it has the README file in there. So that will be all, I think. So you'll find all the configuration snippets and slides a bit later on the following URL. Thank you for attending the session, and do you have any questions, might ask?
Can I ask even a question?
Yeah, sure.
So why? So you said you get this packet, right, in user space in TCP. You send this packet to another server.
Yeah.
That's what proxy does. Why you don't do this like using tables inside the kernel?
Yeah, because that's actually a good question, but in many corporate environments, the people who are using NGINX there, who are trying to push NGINX there, they are not allowed to mess with the system settings. They're only allowed to do one configuration of one application. And that might be easier for them to implement that kind of feature and that kind of functionality, not in operating system side, but in the nginx configuration. Of course, that's going to be slower than if you do it on kernel side. That's obvious. But it gives you a lot of flexibility. It gives you a lot of opportunities to fiddle with your data and actually pick into it easily. Well, that's what we're trying to achieve, at least with nginScript as well. Yeah. So it's about the possibilities, actually. Of course, yeah, you can do it on your operating system as well.
And another, the same question, the same direction, like you're using JavaScript, right, to do the
Well, it's a JavaScript-based language, yeah, I would say.
So you compile it or you run it in Java?
I think it's compiled to bytecode. I'm not actually the person who's developing it, but you might ask Igor on how it's done on technical side. Yes, I think it's compiled to bytecode, and what it does is it's actually quite fast. So I think we've measured that on the same machine that I've had the performance slides from, and I think it used a few nanoseconds to actually copy the JavaScript virtual machine, so it was super fast out there. So instantiation of the machine is fast, it's very fast. With a compiled bytecode already that will handle your requests, your connections, buffers. Yeah, go ahead.
I have two questions. First one, in fact, they are related. Is it possible to configure different upstream server sites? And either return the upstream name from the JavaScript and make a decision based on the request, on applicant to request, and specify which set. Or even if in the stream, if there is such thing as if the if statement is supported, and we know that if is evil and all those stories, but if is supported or any other means that we can, using SNI in the future, since I said that we support it, it will be possible to pick up different backend sets depending on the request.
Yeah, okay. Sure, yes. The simple answer is right now we cannot really choose the upstream group, right? So all the filtering in nginScript happens after we establish the connection with the backend. We are aware of that shortcoming, and it will be fixed by something I think that's called stream phases soonish. We really need that to work for the SNI TLS parsing functionality, because that's basically what's it about. So
for SNI, the expectation is that in the future we still need to do to select the correct upstream in JavaScript, or
no.
Yeah,
it will be available. The SNI thing will be available in the nginx configuration itself. You wouldn't need to involve nginScript at all. Yeah, so it will be built into nginx. Yeah, so in future it will be possible to attach somehow. I have no clear vision of it right now how it will be exactly implemented, but in future it will be possible to receive the connection from the client, receive the data, and actually parse that in JavaScript and then make a routing decision based on that data. So basically we can tell nginx to proxy pass to a specific upstream group. Yeah, not the server in the upstream group.
Can I ask one more question, not related to this with the outside? What is really the use case of marking an upstream server, both HTTP and stream, as marking is down? I mean, when you mark it as down, really, you need to send a signal to nginx and reload the configuration anyway.
Yeah,
so
that's correct.
It's going to be pretty much like commenting out that line or marking the server as down. So what's the advantage really of marking an upstream server as down?
Well, one of the options would be if you don't have any source control management system or a configuration control management system. If you don't want the knowledge of your well, basically, if you have multiple servers and you don't remember actually what's in there, so you can just mark it as down.
No, what would be instead of
okay,
commenting out that line or marking it as down?
Yeah, another option would be to
down is a special option introduced for IP hash balancer, and it allows marking as the particular backend down without rehashing all the other clients. So nginx will only rehash clients which are normally directed to this server marked down. So if you want to decommission a server for a while for maintenance and you use ID hash or hash, you just mark it down and do the work, and then remove the down mark again. So it allows to minimize your hashing. The similar output can be achieved by using consistent hashing, and upstream hash balancer introduced a while ago. But it's a bit more costly, and actually it appeared it's relatively new. So actually, down is mostly for IP hash and normal hashing developments.
All right, so I think we're out of time already, and if you have any more questions on the load balancer module, I'll be at an Ask NGINX booth for the remainder of the day. Thank you.